Hello and welcome to my quick quiz on linear simultaneous equations. There are 20 questions and you will need a pen and a piece of paper to write down your answers. So let's get started. Question 1. Question 2. Question 3. Question 4. Question 5. Question 6. Question 7. Question 8. Question 9. Question 10. Question 11. Question 12. Question 13. Question 14. Question 15. Question 16. Question 17. Question 18. Question 19. Question 20. That's the end of the questions. Let's move on to the answers. Remember, we may not have worked out our answers the same way, but as long as you show all your workings and we have the same answers in the end, you'll be fine. Question 1. Numbering the equations 1 and 2, I subtracted 2 from 1 and then solved to get y equals 4. I then substituted y equals 4 into the first equation, getting x equals 5. I then substituted the y equals 4 and the x equals 5 into the second equation to check, and yes, they both worked, so x equals 5 and y equals 4. Question 2. I started by numbering the equations 1 and 2, then subtracted the second equation from the first equation, getting x equals 5. I then substituted that into the first equation, getting y equals 3. Checking the x equals 5 and y equals 3 in the second equation, I worked out that yes, they both worked, so x does equal 5 and y equals 3. Question 3. I've named the equations 1 and 2. Then because the signs are different on the x, I've added the equations 1 and 2 and solved to get y equals 3. I then substituted y equals 3 into the first equation and solved to get x equals 6. I've checked them in the second equation and x does equal 6 and y does equal 3. Question 4. I've named the equations 1 and 2. Because the signs are different on the y's, I've added both the equations and solved to get x equals 5. I've then substituted x equals 5 into the first equation and solved to get y equals 3. Checking both of them in the second equation, I found that x does equal 5 and y does equal 3. Question 5. I've named the equations 1 and 2, but because the coefficients aren't the same on either of the variables, I've multiplied the second equation by 2. I've then subtracted equation 1 from the new equation and solved to get y equals 5. I then substituted y equals 5 into the original first equation and solved to get x equals 3. I've checked this all in the second equation and yes, it works, so x does equal 3 and y does equal 5. Question 6. I've started off by naming the equations 1 and 2, but because the coefficients on neither of the variables are the same, I've multiplied the first equation by 3 and the second equation by 2. I then subtracted one from the other and solved to get y equals 1. I then substituted that into the first equation and solved to get x equals 5. I've checked them both in the second equation, and yes, x equals 5 and y does equal 1. Question 7. I've started by naming the equations 1 and 2. I then subtracted the equation 2 from equation 1 and solved to get x equals minus 1. Substituting x equals minus 1 into the first equation and solving, you get y equals 1. I checked them both in the second equation, and yes, x equals minus 1 and y equals 1. Question 8. I've started by naming the equations equation 1 and 2, but then I've multiplied the second equation by 5 and the first equation by 2 and renamed them 3 and 4. I subtracted equation 4 from equation 3 and solved to get x equals 0. Substituting x equals 0 into the first equation, I solved and then got y equals minus 3. Checking both answers in the second equation, I got x equals 0 and y equals minus 3. Question 9. I've started by naming the equations equation 1 and equation 2. I've multiplied equation 1 by 4 and equation 2 by 9, and then subtracted equation 4 from equation 3, solving to get x equals minus 2. I then substituted x equals minus 2 into the first equation and solved to get y equals minus 3. I needed to check my answers, so put them both into the second equation, and they worked, so x does equal minus 2 and y does equal minus 3. Question 10. I've started by naming the equations equation 1 and equation 2. I've multiplied the second equation by 2 to get the x coefficients the same. I then subtracted the first equation from equation 3 and got y equals 1. I then substituted y equals 1 into the original first equation and solved it to get x equals 2.5. Substituting x equals 2.5 and y equals 1 into the second equation, it works out that they work okay, so x does equal 2.5 and y equals 1. Question 11. I've named the equations 1 and 2 and then multiplied equation 1 by 8 and equation 2 by 4. I then added equations 3 and 4 and solved to get x equals 2.5. Substituting x equals 2.5 into equation number 1, I solved and got y equals minus 3.25. I then checked both those answers in the second equation and they worked, so x does equal 2.5 and y equals minus 3.25. Question 12. I've started by naming the equations 1 and 2, but they needed to be rearranged so that they're in the same format. I've then multiplied the first equation by 3 and multiplied the second equation by 2, and then added the two new equations together and then solving to get y equals 1. Substituting y equals 1 into equation number 1, I solved and got x equals 3. Checking both of them in the second equation, they work, so x equals 3 and y equals 1. Question 13. The equations are x plus y equals 16 and x minus y equals 2. I've called them equation 1 and equation 2, and then subtracted equation 2 from equation 1 and solved to get y equals 7. I've then substituted y equals 7 into the first equation and solved to get x equals 9. Checking both those numbers in the second equation, they work, so the numbers are 9 and 7. Question 14. The two equations are x minus y equals 8 and x plus y all divided by 2 equals 18. I've multiplied the second equation by 2 and then subtracted equation 1 from equation 3 and solved to get y equals 14. I've then substituted y equals 14 into equation number 1 and solved to get x equals 22. Checking those two numbers in the second equation, they work, so the numbers are 22 and 14. Question 15. I've used E for Estelle and L for Leanne, and the two equations are E plus L equals 45 and L plus 5 equals E. I've had to rearrange them so that they're in the same format, and then subtracted one from the other and solved to get L equals 20. Substituting L equals 20 in the first equation, I solved to get E equals 25. Checking both those numbers in the second equation, they worked, so Estelle has 25 marbles and Leanne has 20 marbles. Question 16. I've used T for Tony and S for Sue, and the two equations are T plus S equals 8 and T plus 2 equals 2S plus 2. I've then rearranged them so they're in the same format and taken one equation from the other and then solved to get S equals 2. I then substituted S equals 2 into the first equation and solved to get T equals 6. Checking both of them in the second equation, they work, so Tony is 6 years old and Sue is 2 years old. Question 17. The two equations are x plus y equals 20 and 2x minus 3y equals 5, and I've named them equation 1 and equation 2. I've multiplied equation 1 by 2 and then subtracted equation 2 from equation 3 and solved to get y equals 7. I've then substituted y equals 7 into the first equation and solved to get x equals 13. Checking both those in the second equation, they work, so my two numbers that I'm thinking of are 7 and 13. Question 18. I've used the variables A for apples and P for pears, and I've changed it into pence to make it easier. So the two equations are A plus 2P equals 104 and 3A plus P equals 127. I've then multiplied the first equation by 3 and subtracted equation 2 from equation 3 and solved to get P equals 37. I've then substituted P equals 37 into equation 1 and solved to get A equals 30. Checking A equals 30 and P equals 37 in the second equation, they work, so we know that apples are 30 pence each and pears are 37 pence each. Question 19. In an isosceles triangle, we know that the base angles are equal, so x plus 2y and 4x minus 5 are equal, and we can rearrange them to get our first equation of 3x minus 2y equals 5. We also know that all the angles in a triangle add up to 180 degrees. So when we've collected like terms, we get 6x plus 2y equals 130. We can then use these two equations and add them and solve them to get x equals 15. Substituting x equals 15 into equation number 1, we can solve this and get y equals 20. We can check that they're correct in equation number 2, which they are. So we know x equals 15 and y equals 20, but that's not the size of our angles. We need to substitute them into x plus 55 to give us our top angle is 70 degrees, into x plus 2y, our angle is 55 degrees, and 4x minus 5, so that angle is 55 degrees also. Question 20. The lengths of a rectangle are equal and the widths of a rectangle are equal. So making them equal and rearranging, we get our two equations of 3x minus 6y equals minus 3 and x minus 5y equals minus 10. But we need to make sure that the coefficients on one of the variables are equal. So I've multiplied my second equation by 3 and solved to get y equals 3. I've then substituted y equals 3 into the first equation and solved to get x equals 5. I've then checked them in the second equation and they work, so x equals 5 and y equals 3. Well, that's the end of my quick quiz on linear simultaneous equations. I hope you enjoyed it. I hope you'll come back to Melissa Maths again soon, and don't forget to hit that subscribe button. Bye!